Okay, so we've been writing this application. It creates a list. We can click on the list. We can see the detail screen. So far, the way that we've been making sure that this application is working is by physically running it in the simulator and testing things ourselves. That's been a relatively short feedback loop for us. Because our app is pretty simple, there aren't a lot of different segues to different view controllers. There's not a whole lot of functionality in there yet that it would take a long time for us to make sure that it's working. That having been said, the way that we've been writing this app has been missing a key component, which is automated testing. As our apps get bigger and more complex, automated testing allows us to ensure that they are working as we make changes in the app and allows us to do things like large refactors with confidence. But there are some other reasons that automated tests provide a benefit to us as well. Let's talk a little bit about why we might test so that we can choose when and whether to test. So, reasons for testing. Testing provides us with a number of things. The first one that we've talked about so far is regression security. So let's call it regression insurance. If you have a large test suite and you're making a big change in an application, then you can run the test suite to determine whether your change has broken anything. This is the main benefit that we tend to talk about when we talk about automated testing. And it is a good one. But it's not the only benefit that we get out of automated testing, and it's valuable to discuss the others. So the second one is documentation. It can be tough from looking at a piece of code to figure out exactly what it's supposed to do and why. But if it has tests that are very clearly named, where each test tells a complete story about something that's supposed to happen with this code, then other developers will be able to pick up our code and use those tests to document what this code is supposed to do. Other developers can also make changes to the tests to run mini experiments to figure out what it is our code is supposed to be accomplishing. Moreover, they can determine whether our code is going to misbehave by introducing a bug situation in a test and determining whether that test passes or fails. Finally, we can use testing as a design aid. This is something that you'll see Avdi Grimm write about at length, the author of our Confident Ruby reading. He says that we can use tests as we are writing code to determine how we might want to structure that code. Coraline Emke talks a little more about why this is when she teaches testing, because she explains that writing a test first allows us to determine what we would like the code to read like in our dream world. We can design the API we want, and because we are building that API first during testing as if we are reading that API, and then later writing that API, our API is designed to be easy to read rather than designed to be easy to write. That's valuable because we tend to spend many multiples of the amount of time reading code that we do writing code. Now, if testing is so valuable, why haven't we done it so far? Well, one of the things about testing is that testing an application, and particularly testing first, is most useful if we already have some idea of what it is we would like the system to do. So I find that it's useful for me to get my hands on an API and try some things in it before I start writing tested or test-driven code in it. Additionally, it is comforting as you are learning a new framework to run the app and see it running. But much like piloting a plane, when we're first learning and we're in a really small Cessna, the main way that we determine where we are and what we're supposed to be doing is by looking at the ground. As we start to drive larger planes and start to take them higher in the sky, we need to rely on our instrumentation to determine that we're at the right height, the right speed, that our engines are working correctly, etc., etc. Similarly, when we're building more complex applications, we need to rely on systems like tests to help us ensure that everything is working properly when we can no longer see the ground all the time. Now that we've talked about some of the reasons for testing, why we didn't test in the beginning, and why we'd like to start introducing testing now, let's go back and take a look at some of our code. We can go back in and test some of the things that we've already written, and we're going to talk about several levels of tests. Unit tests, larger system and integration tests, also risk-oriented tests that appear somewhere in between those levels. But we're going to start with a unit test. A unit test is a test that verifies a specific path through a specific method of a class. And we can write one for our bird class here. Now our bird class has a couple of things in it, right? It has attributes and it has behavior. It only has a little bit of each of those things because it's a pretty small class. And we generally don't worry as much about testing attributes or views when we're doing our unit testing. But we do want to make sure we're testing behavior. And there is one piece of behavior that we have added to this class that it might make sense to test. And that is what happens when we stringify our bird. So we're going to start out our journey into testing by writing a test for that. Over in your project navigator, you see that we have 3 targets. The first is Angry Birds, your app, which is what you've been in for the majority of this time. You'll also see some others. You'll see Angry Birds tests and Angry Birds UI tests. We generated these when we made the app by checking the unit tests and UI tests boxes in the wizard that helps us make an app for the first time in Xcode. Now it's time for us to use those things. I want you to open the Angry Birds tests target. Now, we are going to create tests in here. So what we'll do is with the target selected, I'm going to hit Command N, and I want to go to Unit Test Case Class. We can generate one of these on our own, but iOS will help us with some of the boilerplate if we choose this option. I'm clicking Next. Now, what I want to test is the bird class. So I'm going to call this bird test.swift. We want it to inherit from XC test case. We click Next and create. Now inside of our Angry Birds tests target, we have a new file, birdtest.swift. You'll notice that it imports XCTest, which is a library that we use for testing and assertions in iOS. You'll notice also that bird test inherits from XCTest case, and there are some example tests inside of here for us to look at. There is one more thing that we need to do here, which is we need to import our app target so that we can access classes in our app from our tests. So the way we're going to do that is with testable import Angry Birds. You'll need this at the top of each test file. If your tests aren't running or if they say they don't have access to your classes, this may be what's missing. Okay, so now let's take a look at some of these implementations that have been provided for us. First, we have setup. This is going to run before each test, so we can use it to do any setting up of the environment that we need to do. Teardown similarly runs after each test. We don't need either of these for our unit test example, so I'm going to delete them. Then we have this test performance example. We'll talk a little bit more about that later, but it provides you with a measure block. What measure does in iOS is it gives us the opportunity to set an amount of time that we are willing to afford a block of code to take. And then we can put that block of code inside of measure, and this test will pass if that block of code run 10 times averages lower than the allotment, or the test will fail if that code run 10 times averages a higher runtime than the allotment. We don't need that either for our unit tests. Instead, we are left with test example. This is an example of a functional test case. We will use XCT assert and related functions to verify our tests produce the correct results. I'm going to delete these two comments. There are two important things to note about what we have left. First, you'll notice that the method begins with the word test. That's important. That's part of how the XC test framework in iOS recognizes that a method is a test. Second, you'll notice these two diamonds over here. Those are one way that we can run each of our tests. So if I click the play button here, I can go ahead and run this. Because there are no assertions, of course, we can expect it to pass. It's going to take a minute because the testing setup usually takes a minute in iOS. Throughout our time looking at testing in iOS, you're going to notice that we have a couple of different things that work relatively slowly or maybe unideally. That has something to do with the way that testing is prioritized by the Xcode and iOS teams. It's important to the Apple engineers and the Apple business people that, of course, apps work correctly. But the approach that they generally take to making sure apps work correctly is to prioritize putting features into the Swift language that make it difficult to write apps that don't work. They also provide a lot of design guidelines and design defaults that are supposed to make apps look nice, even with relatively little work. Finally, when you deploy an app to the App Store, it undergoes manual testing at Apple. And the idea is that through that rigorous testing process, through a rigorous language, and through sensible defaults in design, most apps that make it to the Apple App Store will look good and will work well. So for that reason, sometimes we find that testing frameworks and affordances lag a little further behind the other things that the team is prioritizing. It's not that they don't recognize the value of tests or that they don't know how to test. It's that they have prioritized another means of attempting to create robust applications. But using tests is still a valuable tool for us as the creators of end-user applications. Okay, so now we're going to test our bird. I'm going to call this test bird debug description. I want it to be clear in my test name what class I'm testing and what behavior I'm testing. Now, if I were testing multiple different options in the test bird debug description, I might put test class method underscore happy path or stringifies valid inputs. And then I might have another method for the failure case, test bird debug description throws an error when given invalid inputs or something like that. But for now, I'm only going to test one path through test bird debug description. Now, we'll need a couple of pieces to write a good test. The first is given, the second is when, and the third is then. Your givens are the environment that you've set up for your application. Your when is the action or situation that you want to simulate in your test. Your then is the expected and the desired behavior where you make sure that you are getting what you would like from your code. So let's start with our given. We need a bird. Let bird equal bird. I'm going to name this bird American Crow. And I want to give it a description of looking at you like you have just said the dumbest thing it's ever heard. Finally, we need an image URL, which I've gone ahead and provided for you. I'll show you this image and you'll see what I mean with my description of this bird. So this is our test bird. Now, we need a when. And what I'm going to say is let description equal bird dot debug description. So now we're calling on the attribute that we would like to test. Let's take a look at this error that we are getting. Incorrect argument label in call have name description expected named. I made a typo in my argument label. Beautiful. Also worth noting that sometimes when I'm setting up test classes like this with a couple of attributes, I'll put them like this so that they're easier to read. One more thing to discuss is naming conventions in tests. Sometimes people will take the subject that they are testing and they will name it SUT, or subject under test. The SUT convention is particularly popular among the iOS unit testing community, so if you see objects named SUT in tests, that's what that is. Finally, our then block. We want to assert that our expected value is the same as the value that we're getting. Let's say expected value is going to be bird name American crow, description, whatever it is I wrote up here. Beautiful. Finally, I'm going to rename this actual value. Many unit tests, and even some of the higher level tests, ultimately amount to essentially asserting equality between some expected value and some actual value. We will use our built-in assertion, xct assert equal. You'll notice that this method takes two expressions, and it says that those two expressions need to be equatable. Equatable is a protocol in Swift that allows two equatable objects to be compared to one another using the equals operand. So it just so happens that strings come conforming to equatable, which means that you can take one string and ask if it is equal to another string by value rather than by reference. So now let's type in actual value, beautiful, and expected. We assert that our actual value is equal to our expected value. Let's run our test and see if it passes. Our test succeeded. Now, you can ensure that a test is going to fail if the code that it tests doesn't work in a couple of ways if the test is already written. One of those ways is to deliberately set your expected value to something that's wrong and ensure that the test now fails. Good. Another, somewhat more rigorous way to do it is to go to your bird class and remove the implementation that you're testing, and then ensure that your test fails. It's a little less convenient this way. Now you'll notice that I'm no longer on the test class itself, but I can go ahead and rerun my test from right here by coming up to my left-hand menu and going to the test navigator, which is the sixth item from the left in this toolbar at the top. You see my tests here. If I hover over bird test, I have a play button here next to it that I can play in order to run the tests in my bird test class. And we see that the build failed. Value of type bird has no member debug description. So sometimes it can take a little bit of effort to do it this way, which is why part of the reason why folks will advocate for doing the test first. Let's do var debug description string, and let's compute a return value of wrong. So the build succeeded. Let's see if our test passes. Our test fails. And here in the console, we can see that. Our test case started, and then we get an error. XCT assert equal failed. Wrong is not equal to the debug description that we delineated in our test. That's good. That's the right failure, the one that we want to see to ensure that our test is working. Let me remove my fake incorrect implementation and go back to the correct implementation. Good. Let's make one more change to our bird tests. So I've provided this given, when, and then comments. I'm going to remove those, but I'm going to leave the space in between the 3 blocks. It's common in testing to keep these well separated to help tell the story of what's happening. Given this situation, when this happens, then I expect the following result. This makes the tests easier to read for other developers so they can determine what your intent was in writing the class the way that you did.